Yeah,
So,
just do it in there.
CC3 2.1.166.
All right, here's what's up.
problems.
Here's what's up. Please, when you open your bag of tiles, some of you will have different tiles than each other. Some are translucent, so you can kind of see through them. Some are not. That is totally fine. Do not, so grab a seat. I got a lot of people standing, I got a lot of people doing stuff. Please do not pull out the pamphlets. Keep the pamphlet in the bag. Because we don't need that. It's kind of got answers and activities and stuff. We're going to work on our own separately from that. You need, yeah, if yours doesn't have a pamphlet, that's wrong. Somebody took it out and did not put it back in. So, pour out some tiles in front of you. If you're sharing with a partner, pour them out in front of you, both of you. You can do it on your math journal or in your toolkit or whatever. We want to answer a few questions, and while we're answering these, and this is why I think this lesson's fun, we're going to combine 2-1 and 2-2. Go ahead and while you're looking at the tiles, trace them into your notes. Every different tile should be traced. So by the time we trace them all, we should be able to answer how many types of tiles there are. Leave some space between them. They weren't on the table. Why? You're coming in hot. You keep. Everybody came and picked up their own.
Oh my god, this is so happening.
Push all the air around.
I felt something.
Are we like on the next step? Yeah, so are we out of 5? No. Wait. What? So like, where do I do it? I'm just gonna do it on this page. It'll be fine. It'll be fine.
Chapter 6. Yeah, okay. So,
hopefully no one's done.
Also, whatever he talks to me.
You should have multiple of the same tiles.
wait, each type of tile or like each tile?
Each type.
Okay.
Trace each type of tile.
You know what? I don't like any of you. I hate all of them.
Okay, wait, let's trace it. No, it's called what? Okay, I'm gonna trace it, right? It looks like that.
So we're going to see how many times we What do you know about one of those?
Nope, I'm doing it in chapter 5.
Hey, you do not need to be working in your toolkit for math, like in chapter 6, because I mean you can if you want. You don't need to be. You could just be working in your math journal.
Oh, okay.
That's because we're tracing all this stuff.
Can we do it in chapter 5? Can we do it in chapter 5?
If we're never going back to chapter 5 in math, so like we're skipping the rest of that. So if you have space, yeah, do it there.
Oh, okay.
Yeah, that's fine.
Yeah, I'm out.
Hopefully, we have found these types of tiles. Focus, focus, focus.
Wait, so can we still do it in chapter 6?
If you want to, but you gotta label it so you know that it's actually CC3 chapter 3.
Wait, Ian, are we supposed to trace these?
If I look at this bitty square,
No, why?
And a couple of these should be easy because we worked with them on that last test. If I trace this little square, what are we going to label this little unit square? What's its name? Who remembers? It's a 1. Now hold up. The names we put inside are going to be area. Then we want to talk about the dimensions around the edge. What would the dimensions of my 1 square be? 1 by 1. Now the next one that we did work with is this teal tile. This skinny rectangular. Who remembers the name of our skinny rectangular? It's our X tile. Now, is there a way to line that up with our other tile? Well, yeah. They line up on the short edge. Which means that if this is named X, what's the length of my short edge? 1. What's the length of the long edge? Ah. So this X is area. And this is length. What about the square teal tile? Or turquoise, or whatever color this is. It's an X square. Literally called X squared. Which means its dimensions are X and X. Now, hold up. Now tiles we've never seen before. What is this dude? Hard to see up here.
5 by 1.
It's a 5 tile. Trace it. Make sure you have it. It's a type of tile, right? They said every type of tile.
Smells like ramen.
And then you could sketch that we can see that there are 5 individual 1 tiles in there. What about this purple tile? Is that the same as the 5 tile? No. Alright, so I'm going to sketch this over here. Do we know how big it is?
I'm messing up these shapes real bad.
So we have another skinny rectangle. The last skinny rectangle we call it X. No, wait. Ooh. Can this tile line up with, can my purple line up with my unit tile? It can if I turn it like that. So I know that this dimension is 1. Do I know the long dimension? No. More than 5, or at least it's not 5. 6 is too much.
5.75.
Are we sure?
No.
No. Ah, so if we want to give it a variable, let's use y. Which means its length is y. Now, here's my challenge for you. Talk with your group. What is the green tile? What is its name? Talk with your group.
Okay, the blue one matches up with this. What's the blue one? This is the blue one. The blue one has X on this side. This side is X. This side is X. And this side is X. This side is XY. And this side is purple. It's XY, guys. Yeah, the other side goes because it matches up with the blue. Are you done yet? So, yeah. Wait, guys, can we do this? I didn't even do the small one. I'm not good at tracing. So this is y squared. The big one's y squared. No, it is because
All right, who thinks they know the name of the green tile? Ooh, Oliver about launched himself out of his chair. All right, Oliver, what do you think the green tile is called?
It's XY.
Y or YX. Okay. So what? So wait, why are you saying XY or YX? What property are you utilizing there? Commutative. So not communicative, because that means you will give somebody else a disease, a communicative verb. So, why do you say XY?
Because one of the sides, if you take the long Y piece and put it on there, it matches. And then if you take the long X piece and put it on there, it matches.
Ah.
So X times Y equals XY.
So I can label on my paper, my shorter edge is X, my longer edge is Y, and the tile's name is X times Y. We like it alphabetical order. Mathematicians just along the way decided, hey, we'll make things nice. It's easier for your brain to say XY than it is YX. And yeah, you could obviously train yourself with practice, but mathematicians like things in order. Now, this is not a challenge, and drawing goofs it up because of the thickness of your pencil. If I try to line up a 5 tile, or any amount of tiles, with my X edge, it doesn't work. It might look like it's close to 4, but it doesn't work. It might look like it's near, it doesn't work. We cannot quantify X and Y right now. It does not work. You can try to line these up for days. If you use the physical tiles, it will not work. So we don't know what they are right now. But that's okay, because we know that they are X and Y. And mathematicians then are okay with that. Who?
So if you make one of the letters lowercase, you have to make the other one lowercase.
We are working with we're just generally working with lowercase letters. Most. We'll start to use uppercase letters for, we normally use those for like naming points and things like that, like A, B, C, but we have to start at the beginning of the alphabet when we use those. Variables, we just normally use lowercase for things. It's quicker. What about the big old square tile, my big purple dude? Mia?
It's Y squared.
It's Y squared. Or Y times Y. Y by Y. Please make sure you have 1, 2, 3, 4, 5, 6, 7 types of tiles sketched in your notes. Please make sure you have notated the name of the tile, quote unquote, is its area. So when I say get an X squared tile or get an X tile, the name is the area. Any questions? Pretty good. So now when we talk about naming an expression, and some of you already worked on the homework last night, the name of the expression is everything collected together, simplified. So I want your team to discuss What do you think this equals?
A robot.
I'll give you 30 seconds to look at something interesting about this. Do you have a question? That's what I'm wondering. Do you have a question in your mind when you look at this?
Yes.
What are you wondering? And so Alana, hold that up. Hold that up for everyone to see. How's Alana's tile different than mine? What color is Alana's? Purple only, right? If I flip my purple, now wait, so can I call this the red tile? No, right? But I have, so this was flipped up for purple. What do you think the red might mean? Annie? Negative. So when you go to evaluate this expression, realize that red is negative. Now talk as a team to figure out what this expression is. Can you do that?
Oh, I need a purple. Okay, we're good. Okay, so
Who thinks they can tell me the name of this group? What do you think, Rachel? The name of the group. Okay, you're not paying attention. Moving here?
I got the first.
Okay.
Isn't it y squared
This is a y squared.
plus x squared? No, yeah, x squared.
Why?
Because there's two x squareds, and then you cancel out one of the x squareds because it's red.
This makes 0. This is the only x squared that matters. Then plus
All those y's cancel out.
Cancel.
So now you have x plus 5.
Any questions on how we got that? Was that a hand will or no? Alright, try this. Hold on, I'm coming. So I'm going to try to cover up all the stuff before. I'm going to cluster these all together into what they are. This is just random grab from the bag. Talk with your group, shadow group.
we're good. I'm ready. Okay, so none of these. So it's just these.
It's pretty.
Wait. Okay, guys.
Ava, I just heard you say, yeah, that one's easy. All right, what do you got, Ava? Wait, you're saying 2x plus 5. I have a lot of tiles there. How'd you get that? Cancel. Cancel. Ah, everything cancels except for this group right here. Are we understanding this visually? Okay, wonderful. So now, let's say you walk by somebody's desk. Now, you don't have to actually build the collection, but you can if you think it will help you. You walk by somebody's desk, they are not organized, and you see these piles. I need you to give a simplified name for A, B, C, and D. Please, even if you don't make it on your desk, write out the original and then write out the simplified. So don't just write out the simplified, please write out the original as well. Yeah.
So it's only 2x squared. 2x squared plus
Well, one of the x squareds will a positive x squared will cancel out a negative x squared, and vice versa. Then that's like you have 2 minus 1.
2x squared plus 7x squared is 3x. Okay, whoa. Because okay, so the 3x squared and the x squared, so you subtract it, so it's only 2x squared. And then you add the 5 and the 2, and it's 7. And then come the y and 3x. Okay. Plus 7 I know. I figured that out. Oh, he's still real. Fine, let's use the book. It's okay.
Seems like you're the one kind of. Like, it's okay, guys. It's okay.
I lost the page. I don't know where it went.
Nope.
No?
Ow.
Are you sure
Right about
it's
there.
It's right here. Yeah. I'm sorry.
To make sure we're all on the same page, what do I need to group together in A to make life easier? Alex?
You need to group together the 3x squared and the 2x squared.
3x squared.
And the 1x squared.
Oh, and this x squared.
You also need to group together 2 and 5.
Also in a different group, so I will use a different color, the 2 and the 5. Nothing else gets grouped. So then, what do I have when this gets simplified?
3x.
So, I agree, but mathematically, we put the squares first. And we'll get to, so it doesn't matter if you actually do this right now. But the 3x, I'm going to put over here because the higher powers go first. So, we actually put, how many x squareds do we have now?
4x.
So, we put 4x squared. Then we put the 3x. And then, like I said, alphabetical order if you can. Do we have y values?
Yeah.
How many?
1.
Just one y. And then,
7.
now if we had y squareds, we could stick them here with the squares at first. Keep working on B, C, and D. On A, B, C, and D right now? Also, that A, B, C, and D. So, really all I got is just square.
We're in the back class.
I was sitting in the
I'm
car
going to go ahead
on the
and say
side.
these are being the most distraction. These are so that we can run. These are all the same value.
So x, y would wait, x, y would take away 2x, y, so it'd be 1x. So just do x, y.
You're adding. Wait, what is this? What is that? What is that? What? What?
1 plus 5 is equals 6.
3 x y. Okay, so you take 2x y. You take just the x y. No. Okay, so you take the 2x y and the x y, put it together. So like you take both together, so it's 3x y. Right? So then it's 3x y, and then you take the 5 and the 1, and you add them together to 6. So, and then you have 2x squared.
So 3x to 3xy equals 6.
Okay, so then it's 3xy plus 6.
Yeah, that's it. Those,
Yeah, you just have to, that's it.
What's the question?
let's start working on C.
Okay. Wait. That's what you were doing. Like, let's work on C now.
I'm just
So
excited.
can you, could you make the thing on your desk and then show him the math you're doing by visually moving things and groups?
It may always just take so long. I don't know. Okay, so. Look, that really has one. Bad. No, wait. No, it doesn't. Wait, I do simplify. I'm going to take whoa, it can't. Okay. No, I'm out of room. Oh, that's not an X squared. Well, you can put the 4y and 3y and 7y. And then do the 2 plus 3y squared. And then
Are they the same shape? No. Question mark?
No, the 2xy, then you get the x.
No.
4x.
It's a rectangle of its own specific size. Now you could break it into y amount of x rectangles or x amount of y rectangles, but you don't know what x is and you don't know what y is, so that doesn't help us. It's just still x times y. Well, so what? So if we have the rectangle, right, that is like x, y, then I could say this is what, however many y is, each of these are x rectangles, but I don't know how many that is. So I just still end up with y amount of x rectangles, or x amount of y, and I'm stuck where I am. Well, you can't break the x and the y apart from each other, is what I'm saying. So if we look at B, and we look at 2x squared first, because this is the first thing here, is there anything that groups with that? Alana? The x squared, be careful. X squared by itself, so how many x squareds do we have now? So we have 3x squared. Then, I don't have any y squareds. I do have an xy here. Does that group with anything else? Hi. How many xy's do we have now? 3 xy's. And then I have a 1. Does that group with anything? A 5. And then I have any questions on how we got there? On C, if you want to start and look for things in order, start with one of your squares, x squared or y squared. So, boom, if I start with x squared, do I have anything to add with it? Okay. So I just keep it the same. Then on my y squared, okay. Is there anything to add to that?
No. And then you have 3x next.
You're just having me copy the same thing.
4y. And then plus 2. And that's your main.
So wait, I just copied the same thing.
Yeah.
In a different order.
Yeah.
Why? So what do we call the things that can add together when we're talking about it algebraically? We said they get along, they cooperate, they can be added together, they enjoy each other's company. Here,
no, like terms. No, like terms.
this happens because there are no like terms. So this expression is the same as that expression because we just moved tiles. We didn't really make any groups. We just moved where they were. The groups were already made. I already had my 3 x's together. I already had my 4 y's together. All the groups were made. We just put them in a different order. Now, does D have like terms to be added? Yeah. Hold on. Let me capture this real quick. All right. What do I start with? I don't have an x squared, so if I start with y squared, it has nothing to group with. He has nobody. I'm so lonely. All right, what else? 2xy. Anything to group with? Sorry about the color change, just happened. But it's a different tile, so it might. I actually don't want to use red because then you guys might think we're talking negative. Everything we start with is dealing positive. I just wanted you to understand why there was a red side.
4x.
Like terms, same tiles. You may use the rest of this time to work on your homework.
Oh my god.
Oh yeah, please also get the tiles put away, get stuff cleaned up too. You got like a little under 10 minutes. Yeah, please. Mr. Shoop will vacuum these tiles up. He does not have the time to look for blue tiles on blue carpet. Your eyes are better than ours. Please do me a favor and check the floor real quick.